Section 3.1, Factor the greatest common factor from a polynomial. In this section, we'll identify the greatest common factor, or the GCF, of two or more monomials. We'll factor the GCF from a polynomial. We'll recognize when a polynomial cannot be factored, and we'll factor the negative GCF from a polynomial. Recall that the greatest common factor, or the GCF, of two or more integers is the greatest integer that is a factor of all the integers. So let's just say we're trying to figure out what the GCF of 24 and 36 is. So one way that we could do this is we can list all the factors of 24 and all the factors of 36 and then see what they have in common. So we know that 1 multiplied by 24 is 24. We know 2 multiplied by 12 is 24. We know 3 multiplied by 8 is 24. And we know 4 multiplied by 6 is 24. So those are all the factors of 24. And we'll do the same for 36. We know 1 multiplied by 36 is 36. We know 2 multiplied by 18 is 36. We know 3 multiplied by 12 is 36. We know 4 multiplied by 9 is 36. And we know that 6 multiplied by 6 is 36. So then looking at comparing these two lists of factors, we see that they have 1 as a common factor, 2, 3, 4, 6, and 12 as common factors. And since 12 is the largest factor that they have in common, the greatest common factor of 24 and 36 is equal to 12. So there's another way that you can find the greatest common factor rather than listing all the numbers. So we just figured out what the greatest common factor of 24 and 36 is, but you could do a factor tree to determine the greatest common factor. So you can just begin with any two factors of 24. We know 2 times 12 is 24. 2 is prime. 2 factors of 12. 2 times 6 is 12. And then 2 factors is 6. We know that 2 multiplied by 3 is 6. I'll do the same for 36. We know 6 times 6 is 36. We'll break each of those 6's down. 2 multiplied by 3 is 6. 2 multiplied by 3 is 6. So my prime factorization for 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. 36 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 3. And you can see that they have this 2 in common, this 2 in common, and they have a 3 in common. And if we multiply those common factors together, 2 multiplied by 2 is 4, and 4 times 3 is 12. We can get the greatest common factor that way as well. Now we're not going to be doing factor trees in this section, but I am going to do one more like this just so you can see the pattern, because we're going to be finding greatest common factors of monomial terms as well. So sorry about that. We'll do a factor tree for 40. We know that 4 multiplied by 10 is 40. 2 factors of 4, 2 multiplied by 2, those are prime. And then 2 factors of 10, 2 multiplied by 5. I'll do the same for 60. We know that 6 multiplied by 10 is 60. 2 multiples are 2 factors of 6. 2 multiplied by 3 is 6. And we can break 10 down. 2 multiplied by 5 is 10. So 40 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 5. 60 is equal to 2 multiplied by 2 multiplied by 3 multiplied by 5. And you can see they have this 2 in common, this 2 in common, and this 5 in common. And if you multiply those together, 2 multiplied by 2 is 4, and 4 times 5 is 20. So the greatest common factor of 40 and 60 is 20. Okay. So I'm not going to do another one for 12, 24, and 30. So just ask yourself, what is the largest number that will evenly divide into 12, 24, and 30? So the greatest common factor of each of these numbers is 6. Okay? All right. So now, I'm not going to read this page to you. I'm going to talk about it. Let's hop down to the bottom here where it says, it's telling us that the greatest common factor of 15a to the 4th b and 25a to the 3rd b to the 2nd is 5a cubed b. So this 5a cubed b is the GCF, or the greatest common factor, of these first two terms that they've given us. So you can pretty easily see where the 5 comes from. The greatest common factor of 15 and 25 is 5. But let's look more closely at the variable pieces of these terms. So if you looked at the a to the 4th b, you know that if we expand that, that will equal a multiplied by a multiplied by a multiplied by a multiplied by b. And if you expand this a cubed b squared, you would a cubed b squared, you would get a multiplied by a multiplied by a multiplied by b multiplied by b. So now you can see, just like we did the previous prime factorizations, what factors do they have in common? Well, you can see that they have this a in common, they have this a in common, this a in common, and this b in common. So they have 3 a's in common and 1 b in common. And if you multiply that together, a times a times a, that's equal to a cubed b. So that's where a cubed b comes from. So notice the greatest common factor, if you look at the a to the 4th and a cubed, the GCF of that part is a cubed. And the greatest common factor of b and b squared is b. So if you're trying to find the greatest common factor of variable terms, it's going to be, if you're looking, it's going to be whatever the smaller exponent is. And that's what is explained above. Note that the exponent of each variable in the GCF is the same as the smallest exponent of that variable in any of the monomials. Okay? And let's go ahead and look at a new example. Okay? So for instance, looking at D, we have x to the 7th and x cubed. Well, x to the 7th, if you expanded that, that would be 7 x's multiplied together. And if you expanded x cubed, that's 3 x's multiplied together. So all they can have in common is 3 x's, because x cubed only has 3 x's. So the GCF of x to the 7th and x cubed would be x cubed. Okay, whatever the smaller exponent is, that will be the GCF. So let's find the greatest common factor of the two terms in E. Well, we know the greatest common factor of 8 and 12 is 4. The greatest common factor of x squared and x to the 1st would just be x. We have a y to the 4th and a y to the 6th, so the greatest common factor, all they would have in common is y to the 4th. Let's look at F. The largest number that will divide into 9 and 24 is 3. The greatest common factor of a squared and a to the 4th is a squared. The greatest common factor of b to the fourth and b to the third is b to the third. Notice there's a c cubed in the first term, but there is no c factor in the second term, so they can't have it in common. So it's not part of the GCF. So it would just be 3a squared b to the third. Right? Let's practice a few more. So now we're finding the greatest common factor g of these three different terms. So the greatest common factor of 16, 8, and 12 is 4. The greatest common factor of x squared, x to the fourth, and x is x. And notice the second two terms have a y term, but since the first term doesn't have a y term, they don't all have y in common, so that can't be part of the GCF. In h, the greatest common factor of 4, 8, and 12 is 4. The greatest common factor of a squared, a to the third, and a is a. And the GCF of b cubed, b squared, and b to the fourth would be b squared. Now look at I. The greatest common factor of 3 and 7, well, the factors of 3 are 1 and 3, and the factors of 7 are 1 and 7. So the GCF there is 1. They do not have any variables in common. So the greatest common factor of these two terms would just be 1. Now notice here, think of this as being one term and this as being one term. So our first term is 3 multiplied by x multiplied by a plus b, and we have 2 multiplied by a plus b. So what is the greatest common factor of these two terms? Well, the only factor they have in common is the binomial a plus b. The only common factor is the binomial a plus b. Therefore, the greatest common factor is a plus b. Common factors, which are binomials, will occur frequently when we factor by grouping. And that's what we will be doing in the next section. All right. The process of factoring a polynomial is the reverse process of multiplying polynomials, which we did in Unit 2. To factor out the greatest common factor means to express the original polynomial as the product of the GCF and some new polynomial. And let me explain this to you a little more. So, in Unit 2, when we multiplied, let's say we multiplied 5a times the trinomial y squared plus 3y plus 1. We had to distribute, and recall that we added our exponents. 5y times y squared gave us 5y cubed. 5y times 3y gave us 15y squared. And 5y times 1 gave us 5y. So 5y is a factor. Y squared plus 3y plus 1 is a factor. We multiplied those together and we got the product 5y cubed plus 15y squared plus 5y. So now we're going to start with the product, and you know how to find one of the factors because I just showed you how to find the greatest common factor of a polynomial. We know that the GCF of 5, 15, and 5 is 5, and the GCF of y cubed, y squared, and y is y. So 5y is the greatest common factor of the trinomial 5y cubed plus 15y squared plus 5y. So then, if we divide each of these terms by a 5y, we can find the other missing factor. So 5y cubed divided by 5y is y squared. 15y squared divided by 5y is 3y, and 5y divided by 5y is 1. And it makes sense that we would be using division to undo multiplication. So this is what we're going to be doing now. So here's a procedure for factoring out the greatest common factor. First, you're going to identify the greatest common factor of all the terms of the polynomial. So identify the GCF. Then you're going to divide each term of the polynomial by the GCF to find another factor. Then you're going to write the original polynomial as the product of the GCF and the other factor. And then just note, to check the factorization, you can multiply the polynomials to remove the parentheses. So let's factor these. 5a plus 5. Well, the first thing we're going to do is, what is the greatest common factor of those two terms? And that would just be 5, because there's no a with the other 5. So there's my GCF 5. And then I'm going to divide each term of this polynomial by 5 to find my missing factor. 5a divided by 5 is a, plus 5 divided by 5 is 1. And notice if we checked it, 5 times a is 5a, and 5 times 1 is positive 5, which is what we started with. Okay? Look at the next example. We have 2x to the fourth minus 4x. We're factoring this now. What is the greatest common factor of 2x to the fourth and 4x? And that would be 2x. And then we'll divide each of these by 2x. 2x to the fourth divided by 2x is x cubed, minus 4x divided by 2x is 2. C, another binomial. The GCF of 6 and 12 is 6. Notice they don't both have an a term, or the variable a, so that can't be part of the GCF. The GCF of b cubed and b squared is b squared. So now I'll divide each of these by 6b squared. I will get a squared b minus 2. All right, let's factor these trinomials. The greatest common factor of 2x squared, 8x, and 12 is 2. Can't factor out an x because there's no x with the 12, so I'm just going to divide each of these terms by 2, and I will get x squared plus 4x minus 6. The next one, 5y cubed minus 20y squared plus 10y. The GCF of 5, 20, and 10 is 5. And the GCF of y cubed, y squared, and y is y. And I'll divide each of these by 5y. Y cubed divided by y is y squared, minus 20y squared divided by 5y is 4y, plus 10y divided by 5y is 2. This is also a trinomial, f. The greatest common factor of 9, 3, and 6 is 3. The GCF of x to the fourth, x cubed, and x squared is x squared. The GCF of y to the fourth, y cubed, and y to the fifth is y cubed. Divide each of these by 3, x squared, y cubed. So 9x to the fourth, y to the fourth divided by 3x squared, y cubed is 3x squared y minus x cubed, the y cubed, x cubed divided by x squared is just x, plus 6 divided by 3 is 2. Y to the 5th divided by y to the 3rd is y squared. Right, the greatest common factor of the polynomial 2x plus 5y is 1. So if we factored out the greatest common factor, we would have 1 multiplied by 2x plus 5y. A polynomial whose only factors are itself and 1 is called a prime polynomial. A prime polynomial cannot be factored any further. All right, let's factor these. G, we have a binomial. The GCF of 10 and 15 is 5. The GCF of x squared and x is x. The GCF of y and y cubed is y. The GCF of z squared and z is z. And so I'm going to divide each of these by 5xyz. (10x squared z squared divided by 5xz is 2xz plus 15 divided by 5 is 3, and y cubed divided by y is y squared. H, notice our first term we have 2a to the 5th b cubed. And the second term is 3xy cubed. Well, the GCF of 2 and 3 is 1. Notice they don't have any variable terms in common, okay? Which means we cannot factor this any further. It's prime. Cannot factor it. Now, usually it's advantageous to factor out the opposite of the GCF when the leading coefficient of the polynomial is negative. In other words, if the leading coefficient is negative, we're going to factor out the negative GCF. And notice that this changes the signs of the remaining terms that are inside the parentheses. So notice in I, the leading term, negative 3y cubed, the leading coefficient is negative. So the GCF of 3, 9, and 24 is 3. But since the leading term is negative, we're going to factor out a negative 3. And then we also have to factor out a y. So we'll divide each of these by negative 3y. So it's going to change the signs of each of the terms of the factor that's inside parentheses. Negative divided by a negative, negative 3y cubed divided by negative 3y will give me a positive y squared. Positive 9y squared divided by negative 3y will give me a negative 3y. Negative 24y divided by negative 3y will give me a positive 8. Okay. In the next example, the GCF of 16, 8, and 48 is 8. But since the leading term is negative, I'm going to factor out a negative 8. The GCF of x squared, x cubed, and x squared is x squared. The GCF of y, y to the 4th, and y squared is y. Okay, so there's my GCF. I'm going to divide each of these by negative 8 x squared y. Negative 16 divided by negative 8 is 2. (8x cubed y to the 4th divided by negative 8 x squared y is going to equal negative x y to the 3rd. And then we have 48 divided by negative 8, which gives me a negative 6. Y squared divided by y is y. All right, and that brings us to the U-tries, so I'm going to just go ahead and stop there. So that concludes lesson 3.1.